Krakatoa sat quietly in the strait between Java and Sumatra, and when it finally spoke, it produced the loudest sound in recorded human history. It killed more than 36,000 people, generated tsunamis taller than buildings, and altered the climate of the entire planet. Months later, schoolboys on a beach in Zanzibar, 4,500 miles away, would find a floating raft of black pumice tangled with human skeletons, monkey bones, and even tigers. The 1883 eruption of Krakatoa wasn't just a natural disaster. It changed science, global communication, and our understanding of just how powerful the earth beneath our feet truly is. To understand what happened in 1883, you need to know what Krakatoa was before it tore itself apart. The island sat in Indonesia's Sunda Strait, right along the convergence of the Indian, Australian, and Eurasian tectonic plates. One of Earth's most volcanically active zones, Krakatoa wasn't a single peak, but three volcanic cones, Perbawewatan in the north, Danan in the middle, and Rakata, the largest, forming the southern end. Together, they created an island roughly 5 kilometers across, densely vegetated, rising out of warm tropical waters. Krakatoa had earned its reputation. Local Javanese communities called it the Fire Mountain. A massive eruption in the distant past, possibly in the 5th or 6th century, had shaped the island and its neighbors, Lang and Verlaten, blasting out the wide undersea caldera that cradled them. Here, it's worth clearing up a story you've almost certainly heard. For years, popular history has blamed Krakatoa for the great global darkness of the year 536, when the sun dimmed for months, crops failed across the northern hemisphere, and the classical world began to unravel. It's a gripping idea, but the modern science no longer supports it. Drilling in the Sunda Strait has found no trace of any Krakatoan eruption at that time, and the old Javanese chronicle the theory leans on actually dates its cataclysm to the year 416, not 536. Ice cores now point the finger far to the north instead, toward a high-latitude eruption, possibly in Iceland, perhaps joined by others in North America, an episode geologists call the Late Antique Little Ice Age. Krakatoa, as we're about to see, has more than enough real history to answer for. The only confirmed eruption before 1883 was a moderate event in 1680. After that, silence. 200 years of it, 2 centuries during which jungle reclaimed the slopes. And the world forgot what Krakatoa could do. Then came May 20th, 1883. That morning, Perbawewatan, the northernmost cone, awakened. Strombolian activity began. Steam vented regularly, and ash-laden clouds climbed 10 kilometers high. The explosions echoed in Batavia, modern-day Jakarta, 100 miles away. The German warship Elizabeth happened to be nearby and became the first vessel to document the renewed activity. Something was stirring inside Krakatoa, but nobody panicked, not yet. People were actually curious. On May 27, a steamship carrying tourists from Batavia arrived at the volcano. They had watched explosions during the night, felt earthquake shocks, and still came for a look. The eruption had become a spectacle, something worth a weekend trip. Through late May and into June, the activity came and went. It would flare up, quiet down, then flare up again. By June 19th, volcanic activity resumed in earnest. But the region had grown accustomed to the rumblings. People in the coastal towns of Java and Sumatra went about their lives. Fishermen cast their nets. Farmers tended their crops. The volcano grumbled, and life continued. Until August 26th. At 1 o'clock in the afternoon on August 26th, 1883, the first of increasingly violent explosions rocked Krakatoa. By 2 o'clock, a massive black cloud of ash had risen 27 kilometers into the sky. A column so tall it punched deep into the stratosphere. This was no longer a curiosity. This was a crisis unfolding in real time. At 5:07 p.m. Greenwich Mean Time, the first truly violent explosion occurred. The sound carried across the strait. Ships in the region began taking notice. Captain J. Proutz, aboard the vessel Hope, moored near present-day Jakarta, reported that it became dark as night and rained down ashes as fine as dust or sulfur powder. Throughout the night of August 26th into the 27th, explosions were heard every 3 to 4 hours, sounding like distant heavy gunfire. The darkness was nearly total. Ash rained down continuously, and the explosions were building, each one larger than the last. Then came August 27th, the day that changed everything. At 5:30 a.m. Greenwich time, a second massive explosion tore through the island. At 6:44 a.m., a third followed. Each blast sent shockwaves radiating outward. Each generated tsunamis that raced across the strait. But none of it compared to what happened next. At 10:02 in the morning local time, Krakatoa unleashed its climactic explosion. Volcanologists classify what happened that morning as a Plinian eruption, the most violent category, named for the towering ash columns first described by Pliny the Younger at Vesuvius. And much of its ferocity came from a phreatomagmatic reaction, seawater meeting molten rock, and flashing instantly to steam. This single blast measured 6 on the volcanic explosivity index and carried the force of 200 megatons of TNT. To put that in perspective, the atomic bomb dropped on Hiroshima in 1945 had a force of 20 kilotons. Krakatoa's final explosion was nearly 10,000 times more powerful. It remains the loudest sound in recorded human history. The blast registered an estimated 310 decibels. Anyone standing within 10 miles would have been rendered instantly deaf. On the RMS Norham Castle, roughly 40 miles away, the shockwave ruptured the eardrums of sailors on deck. A barometer at the Batavia Gas Works, 100 miles from the eruption, registered the pressure spike at over 2.5 inches of mercury, equivalent to more than 172 decibels. And the sound didn't stop at 100 miles, or even 1,000. The explosion was heard clearly 3,000 miles away, nearly 5,000 kilometers across the Indian Ocean. People in Australia, the Philippines, and the island of Rodrigues near Mauritius reported hearing what they thought was cannon fire, 3,000 miles. That's roughly the distance from New York to London, but it's the pressure wave that truly defies comprehension. The shockwave generated by the explosion was recorded on barographs in more than 50 cities worldwide. And it didn't just register once. The wave circled the entire globe, 3.5 times, over 5 days, producing a detectable spike in air pressure roughly every 34 hours, passing and repassing monitoring stations, like some ghostly echo of the original blast. While the sound wave traveled the globe, immediate horror was playing out across the Sunda Strait. 2/3 of Krakatoa simply ceased to exist. The northern portion, including the cones of Perbuewatan and Dainan, collapsed into the emptied magma chamber below, forming a submarine caldera. The eruption ejected approximately 25 cubic kilometers of rock and ash. The column reached 80 kilometers into the atmosphere, and as the island collapsed, as pyroclastic flows roared across the water's surface, the sea itself rose up. The tsunamis generated by the eruption were catastrophic beyond imagination. Along Java's west coast, waves reached 42 meters, 138 feet. The town of Merak was obliterated by a wall of water 46 meters high, nearly 151 feet. Along Sumatra's south coast, waves reached 24 meters. The waves were so powerful that coral blocks weighing 600 tons were picked up and hurled ashore like pebbles. More than 300 villages and settlements along the Sunda Strait were completely destroyed. On the island of Sabesi, closest to Krakatoa, 3,000 residents lived there. Not a single one survived. A Javanese farmer named Ahmed, who was near the town of Merak, later described what he saw. He watched a great, black thing approaching. It was very high and very strong, he said, and we soon saw that it was water. Around noon on August 27th, a rain of hot ash fell on the town of Ketimbang in Sumatra, an event that became known as the Burning Ashes of Ketimbang. Approximately 1,000 people died, not from water, but from superheated volcanic debris falling from the sky. The wife of a Dutch controller named Beierink, stationed in Sumatra, left one of the most harrowing accounts of the disaster. As the world went black around her, she described the ash being pushed up through the cracks in the floorboards, like a fountain. She heard her husband say, in despair, Where is the knife? I will cut all our wrists. And then we shall be released from our suffering. Sooner. In all, the official death toll recorded by Dutch colonial authorities was 36,417. More than 34,000 of those deaths were caused by the tsunamis. Some modern estimates put the actual toll as high as 120,000. In the aftermath, the scene was apocalyptic. Observers reported thousands of corpses and animal carcasses lying in tangled masses, jammed together with coconut palms and home wreckage. The stench indescribable. And then, 9 months later, in May of 1884, something deeply unsettling was found. Schoolboys walking along a beach on Zanzibar Island in East Africa stumbled upon a massive raft of black pumice. Tangled within it were the bleached bones of dozens of human skeletons, intertwined with the skeletons of monkeys, and 2 tigers. They had floated more than 4,500 miles across the Indian Ocean, silent passengers on a current that carried them from one side of a continent to the other. But Krakatoa's reach extended far beyond the Indian Ocean. The eruption injected an estimated 20 million tons of sulfur dioxide into the stratosphere. There, it formed a global veil of sulfuric acid droplets that reflected incoming sunlight and reduced global temperatures. In the year following the eruption, average summer temperatures in the northern hemisphere dropped by 0.4 degrees Celsius. Some measurements suggest global temperatures fell by as much as 1.2 degrees, with effects persisting for 5 or more years. Krakatoa had triggered a volcanic winter, and as violent as it was, Krakatoa wasn't even the worst its own region had produced. Just 68 years earlier, and a few hundred miles to the east, another Indonesian volcano, Mount Tambora, had erupted in 1815 with a force rated 7 on the Volcanic Explosivity Index, 10 times more powerful still, and the largest eruption in recorded history. Tambora's veil of dust chilled the planet so severely that 1816 became known across Europe and North America as the year without a summer, a season of frost in July, failed harvests, and famine. Krakatoa was the louder, more famous catastrophe. Tambora was the deadlier climatic one. Together they made the Sunda Arc the most dangerous volcanic neighborhood on Earth. The atmospheric effects were visible. Vivid, blood-red sunsets blazed across the skies of Europe and North America. In New York, Poughkeepsie, and New Haven, the sunsets were so intense, so searingly crimson, that fire engines were called out to fight what residents believed was a massive conflagration on the horizon. They weren't looking at fire, they were looking at the atmospheric fingerprint of a volcano 4,000 miles away. And red was only part of it. The color depended on the size of the dust suspended high in the air. Where the particles were finest, the skies bled scarlet. Where they were a fraction larger, observers from Borneo to Hawaii watched the sun, and even the moon, rise in eerie blue or green. Around the sun itself hung a vast pale halo that lingered for months, first described from Honolulu by the Reverend Sereno Bishop, and known ever since as Bishop's Ring. Those skies became a subject for both science and art. The British artist William Ashcroft was so captivated that he produced hundreds of color sketches of the sunsets from the banks of the Thames in London, timing each one as the hues shifted, an extraordinary visual record of the eruption's atmospheric legacy. In the pages of the scientific journal Nature, an obscure schoolmaster and poet named Gerard Manley Hopkins published a series of letters describing the spectacle in aching detail, writing that the glow was more like inflamed flesh than the lucid reds of ordinary sunsets. They were among the only writings he saw published in his lifetime, and 10 years later, in 1893, the Norwegian painter Edvard Munch stood on a hillside overlooking Oslo and painted a figure with its mouth open in a silent howl against a sky streaked with orange and red. That painting was The Scream. The sky Munch painted wasn't imagined, it was remembered. It was the sky Krakatoa had given the world. The 1883 eruption was also a landmark in the history of science and communication. It was, in many ways, the first global news event of the modern age. Telegraph cables had recently been laid across the ocean floor, and they carried news of the disaster around the world within hours. People in London and New York were reading about Krakatoa while the ash was still falling. The Royal Society of Great Britain assembled a dedicated Krakatoa committee to collect accounts of the eruption and its effects from more than 800 locations worldwide. Their comprehensive report, published in 1888, remains one of the most thorough studies of a volcanic event ever produced. That report did more than chronicle a disaster. It built a method to make sense of the airwave that had circled the planet. The committee's investigators worked out how to read the rhythmic spikes on barographs around the world and time each pass of the wave. For 139 years, that wave stood alone, the only volcanic pulse ever known to have rung the entire atmosphere, like a bell. And then, it happened again. On the 15th of January, 2022, an undersea volcano called Hunga Tonga Hunga Ha'apai erupted in the South Pacific. Its pressure wave raced around the Earth multiple times, the only event in well over a century to rival Krakatoa. When modern scientists set out to measure it, they reached back and used the very method the Royal Society had devised in 1888. A blast from the Victorian age had handed the 21st century the tools to understand its successor. Meanwhile, Dutch geologist Rogier Verbeek, who had conducted research in the area just 2 years prior and witnessed the eruption from his home on Java, was commissioned by the Governor-General of the Dutch East Indies to produce an official investigation. His resulting work, published in 1884 and 1885, brought the science of volcanology into mainstream scientific prominence. And weather watchers tracking the atmospheric effects of the eruption noticed something no one had described before. The sulfuric haze spread along a consistent, narrow band around the equator. They called it the equatorial smoke stream. Today we call it the jet stream. Krakatoa's eruption led to its first identification. There was a quieter legacy too, one that took decades to reveal itself. The eruption had scoured the surviving islands down to bare, sterile rock. Every living thing had been erased. To biologists, that was an almost unrepeatable gift, a blank slate on which to watch life return from nothing. Year after year, expeditions cataloged the new arrivals. First a single spider riding a thread of silk, then ferns and grasses, then insects, birds, and trees carried in on wind, current, and wing. Those painstaking surveys became the founding natural experiment of an entire field. When Robert MacArthur and Edward O. Wilson built their landmark Theory of Island Biogeography in 1967, one of the cornerstones of modern ecology, it was Krakatoa's recolonization data that they used to test it. The dead island had become one of the most important living laboratories in the history of biology. The eruption's reach was not only physical and scientific, it was political. In the ruined, grieving communities around the Sunda Strait, the catastrophe fed a rising current of religious and anti-colonial feeling against Dutch rule. The historian Simon Winchester has argued that the misery Krakatoa left in its wake helped stoke the militancy that boiled over in 1888, in the Bantonese uprising at Silagan, when rebels declared a holy war and fell upon the colonial administration, an episode many now regard as a way station on the long road to Indonesian independence. Whether the volcano was a cause or merely a catalyst is still debated, but few doubt it deepened the desperation that lit the fuse. The eruption may even have left its mark on the planet's balance. By some estimates, the sheer redistribution of rock, water, and shattered mountain nudged Earth's axis by as much as 17 centimeters, a measure of just how much mass the explosion moved in a single morning. One of the most remarkable survival stories from the disaster belongs to the ship Gouverneur General Loudon and her captain, Johan Lindeman. As the eruption worsened and the first tsunamis began sweeping the strait, other vessels scrambled for port. Lindeman made a different choice. He turned his ship directly into the oncoming wave, riding head-on into the tsunami rather than being caught broadside. His decision saved the lives of every passenger and crew member aboard. Not every vessel was so fortunate. The steamship Barrow was picked up by a wave and carried 2.5 kilometers inland, killing all 28 crew members. The story of Krakatoa didn't end in 1883. On December 29, 1927, 44 years after the cataclysm, fishermen in the Sunda Strait noticed something strange: bubbles, steam, a disturbance in the water directly above the point where Krakatoa had collapsed. From the caldera of the old volcano, a new island was rising. They called it Anak Krakatau, the child of Krakatoa. By 1930, Anak Krakatau had permanently risen above sea level and continued growing at an average rate of 7 to 9 meters per year. The child was becoming a mountain, but it inherited its parents' temperament. On December 22, 2018, Anak Krakatau experienced a massive flank collapse during an eruption. Approximately 2/3 of the island's volume slid into the sea, reducing its height from 338 meters to just 110. The collapse generated a tsunami that struck the coasts of Java and Sumatra with waves up to 5 meters high, killing 437 people and injuring more than 14,000. And this time, the danger announced itself in a way no instrument was listening for. The collapse was a landslide, not an earthquake. It sent out no sharp seismic jolt racing ahead of the water. And so Indonesia's tsunami warning network, tuned for decades to detect the telltale shaking of a quake, never sounded. The waves arrived in darkness, without warning, on a holiday weekend when the beaches were crowded with families. It laid bare a hard truth that Krakatoa itself had first hinted at in 1883, that the deadliest waves can be born not from the seabed heaving, but from a mountain falling into the sea. Researchers are now racing to close that gap, developing new systems, some using artificial intelligence, some listening for the slow, low rumble these collapses do produce to catch the next one in time. Recent research published in late 2024 revealed something chilling. Satellite radar data showed that Anak Krakatau's flank had been slowly slipping along a detachment fault for years before the 2018 collapse, accumulating approximately 15 meters of movement between 2006 and 2018, with notable acceleration before the disaster. The danger had been visible from space, if anyone had known where to look. Today, Indonesia's Center for Volcanology and Geological Hazard Mitigation monitors Anak Krakatau around the clock using seismometers, tilt meters, and satellite thermal imaging. As of early 2026, the alert level remains at level 2. Gas plumes still rise from the vent. The volcano is quiet, but it's not sleeping. Scientists say that another eruption on the scale of 1883 is extremely unlikely, but another flank collapse, another tsunami, that's the concern that keeps volcanologists watching. Dr. Martin Mangler of the Natural History Museum in London put it simply: the eruption of Krakatau is a striking example of the irrepressible force of nature. Within a heartbeat, volcanic eruptions can reshape the entire planet in many different ways. In August of 1883, the world heard that heartbeat. It heard it 3,000 miles away. It felt it circle the globe. It saw it painted in the sunsets for years afterward. And today, rising from the same waters that swallowed its predecessor, the child of Krakatoa reminds us that the Earth has a long memory, and it's never truly finished.